triple integrals in other coordinates. So 14.6, we talked about the triple integrals basically in rectangular form, x, y, and z. So remember we had some problems where we said just set up the triple integral but don't solve. There's a reason for that. It can take quite a while to solve certain triple integrals in rectangular form. It may be easier if you can convert the triple integral to cylindrical, which is simply polar coordinates in the third space, or spherical. So back in chapter 11, you recall that we gave the introduction to cylindrical coordinates and spherical coordinates. So here we make use of that from this point on, because as you go through, if you're given a triple integral, you have the choice then to decide if you want to solve that using rectangular, cylindrical, or spherical. That becomes your choice later on. So you decide which would be easier to solve. So in terms of cylindrical coordinates, we'll look at this and work a problem or two. If you go from rectangular, again, it's still the same solid Q. So we're taking the triple integral over the solid with respect to the change in the volume. But here, this is a function, right? So this is some f of x, y, z. So this is not the volume. If I didn't have that function there, then we do have the volume. Right? We convert this to cylindrical coordinates. Remember, x is r cosine theta, and y is r sine theta. For cylindrical, you think it's the same as polar, but for polar coordinates, you're only concerned with x and y. If you talk about polar coordinates in the third space, x, y, z, you just change the name and just call it cylindrical. So it's the same thing. So here for cylindrical coordinates, z stays the same. Z is z, right? So you have x, y, and z. You remember back for the polar coordinates, you had to have that r factor, r dr d theta, but now for the triple integral is r dz, don't forget that now, dr d theta. For spherical coordinates, there's a factor for that for the volume. Here for cylindrical, it's an r factor, but for spherical coordinates, it'll be rho square times sine phi. And if we do get time, I may give you an outside assignment where in the assignment, it is to investigate the average temperature over the Earth. And when you do that, you have to prove a subconsequence to be able to get the Earth's sphere to act right for the calculation. And in ensuring that this sphere, the Earth, that you're able to calculate this average temperature, you end up proving that rho square sine phi factor for spherical coordinates. That's pretty neat. I typically reserve that for certain semesters. If I find it, I may give that to you so you can kind of look at that outside. I think you'll really enjoy it. Okay. Let's look at a problem. Evaluate here the triple integral. Let me work through these. I got 30 minutes and I want to finish this section, and we're in the process of hiring 2 new math instructors, and I got interviews at 10:30, so, and I'm the chair for that. So let's see. The neat thing about this triple integral is that it's set up for you. So here you just integrate. So should make it a whole lot easy for us. So this is the integral from -1 to 5, the integral from 0 to power over 2. Integrate first with respect to r. So this is r squared over 2. R is evaluated from 0 to 3. You have that cosine theta, d theta, dz. So we get 9 over 2 on the outside times the integral from 1 to 5, the integral from 0 to pi over 2 cosine theta d theta dz, excuse me. Integrate with respect to theta. We have that 9/2 sitting outside. Integral from -1 to 5. This becomes sine theta. Sine is evaluated from 0 to pi over 2. Well, that just gives us pi over 2. So this is 9 over 2. Sine of pi over 2 is just 1. Integral from -1 to 5 dz. So this is just 9/2 times z. Z is evaluated from -1 to 5. So this is 9 over 2 times 5 minus -1 is 6. $27. So on the test, I will have a problem like this where the triple integral is set up and you solve it. Here, this is cylindrical coordinates. Then I have another problem. It'll be set up in spherical form. You solve that. But then I have a problem where it's a triple integral and it's given to you in rectangular form. You have to convert it to cylindrical and also spherical, and then they ask the question, you solve the easiest one. So now for the spherical coordinates, hope that was your phone. Hope that's your phone too. Or if not, you had some eggs last night. So this is theta, and this is phi. Z. This is R, Y. That's rho. So if I pull that top one out, cosine phi is this C over rho, and sine phi is R over rho. So we get R is this rho times sine phi. We also get from here that Z is equal to rho cosine phi. So you remember that x is equal to r cosine theta, but replace the r here with rho sine phi. So you get x equal to r, that is the rho sine phi, times cosine theta. And then y is equal to r, but here r is the rho sine phi times sine theta. And then z is equal to the rho times cosine phi. Now, when we try to approximate the volume in spherical coordinates, I need to go in and partition, that is, cut up this image, this graph, in sectors of the same size, so cubes of the same dimension. And so here, these cubes, when they work themselves out, you get this volume for each cube that has a factor of rho sine phi times the change in theta. Here's what you need. And with this, you can solve any of the problems from rectangular to spherical. You need this formula here. This is this triple integral. Now this is x, this is y, this is z. That factor for the volume comes out to be rho square sine phi. That's the factor that always goes into the triple integral for spherical coordinates. And then d rho, d phi, d theta. Again, you can change up those orders if you want, and that's fine. This factor here is interesting, and I will see if I could find my outside assignment to give you some work with that to see how this is actually produced by computing the volume in triple integrals for spherical coordinates. Where does that come from? In Calculus 2, when you started talking about Chapter 11 with the introduction to vector analysis, we talked about a parallelogram, and then from that parallelogram you were able to approximate the area using the norm of the cross product. If you remember that, go back and look at it. That's exactly how they produce computing this volume. Basically, it becomes that area, the norm of the cross product, and then times some height. And so you end up with this, it looks like it's rho times sine phi, which is one side, and then the other side is phi. And you end up with, one side is rho. So it's rho times sine phi times rho. You end up with rho squared times sine phi. But I have a very neat assignment, and you're able to get it, and you get excited. I get excited when you're able to produce it, and you see where it makes sense within the problem. Well, here, this is a triple integral that's in spherical. Let's see if we can solve this. So this is the integral from 0 to power 4, then the integral from 0 to power 4. We're going to integrate first with respect to rho. That becomes rho cube over 3. Here, rho is evaluated from 0 to cosine theta. This is sine phi, cosine phi, d theta, d phi. So we have a 1/3 sitting out there, the integral from 0 to power 4, the integral from 0 to power 4. And this is cosine cube theta. Let me put next to it. Well, it's just a sine phi cosine phi. This is d theta d phi. I believe it was calculus 2. We had the section dealing with solving an integral with trigonometric functions. If you had cosine cube theta or d theta or cosine cube x dx, or if it was sine cube x dx, it gave you a procedure. That is to look at the cosine cube as cosine squared times cosine, take the cosine squared and write it as 1 minus sine squared theta times that third cosine. So this is 1/3 times the integral from 0 to power of 4, the integral from 0 to power of 4. This is 1 minus sine squared theta times cosine theta. This is sine phi cosine phi d theta d phi. This is 1/3 times the integral from 0 to power of 4. Bless you. It's the integral from 0 to power of 4. This is cosine theta minus sine squared theta times cosine theta. Keep that there. Then we have here sine phi cosine phi d theta d phi. Now let's integrate with respect to theta. Now for this one, let u equal to sine theta, and du picks up the cosine theta right next to it, d theta. So this is 1/3 integral from 0 to power of 4. Integrating with respect to theta, the integral of cosine is sine theta. This is minus, if u is sine, so then when I integrate u, I get u to the third divided by 3. So that is, the u is sine, so u to the third is sine cubed theta all over 3. Here we evaluate the thetas from 0 to power of 4. On the outside we have sine phi cosine phi d phi. Now evaluate at power of 4. So we get 1/3 integral from 0 to power of 4. This is just 1 over the square root of 2 minus 1 over the square root of 2 to the third times 1/3. And this is sine phi cosine phi d phi. Simplify that information. So this is 1/3 times the integral from 0 to power of 4. This is 1 over the square root of 2 minus 1 over 2 times the square root of 2 times that 3, put a 6 there. Times sine phi cosine phi d phi. Now I can simplify this one more time. Make this denominator 6 times the square root of 2. So this becomes 6 minus 1 sine phi cosine phi d phi. Thank God for algebra, right? Boy, I tell you, that algebra is so important. So this is, I have a 5, and then downstairs I have a 3 times that 6. That's 18 times the square root of 2 times the integral from 0 to power of 4 sine phi cosine phi d phi. And what you think? I wrote on my paper, omit. I didn't want to tackle the algebra either. But suffer it be so now. It becometh us to fulfill all righteousness. The words of our Lord to John the Baptist. So this is 5 over 18 times the square root of 2. I'm going to use a u du for this as well. Let u equal to the sine and so du picks up the cosine phi and that d phi. So that becomes u squared divided by 2, where u is this sine square phi all over 2. It's evaluated from 0 to power of 4. This is 5 over 36 times the square root of 2. And this is 1 over the square root of 2 to be squared. So this is 5 over 36 times the square root of 2 times 2. This is 5 over 72 times the square root of 2, or 5 times the square root of 2 over 144. I had a student to email me last night. He had a question about how come some of the problems on the test they had never seen before. And my response to him, I typed a long sermon. Yeah, typed a long sermon. Because yes, sir. Yes, sir. That's just life itself. Yes, sir. Well, here's what happens. You can't get this information by studying problems. A lot of students take these classes and they spend a lot of time working problems. So that means that you can master a problem. But if I change the problem, change the wording, does that throw you off? If it does, it means that you mastered the problem and not the concept. Study the concept. We used to go feed those hogs, and we throw that slop down, and those hogs, they never look up and tell you thank you. They put their head down there and them short. But every now and then you look up at the Creator and say, thank you. I see what you're doing. So many times we're looking at the problem, looking down, they're like those hogs, and just say, okay. I said they fight too, you know. They throw some more food over there, they go, you know. You got some food over here? Well, they just look down, you know. But man, look, when they learn to look up at my granddaddy and see what he's holding in his hands and see where he's going, that's the key. You follow him. You can't get this by focusing on a problem. You're looking down. Look up. David even said, I lift up my eyes unto the hills. He was looking at Saul, and Saul had him depressed. He kept looking down. But then he looked up. He was in that cave, and he came out and looked up. He said, oh, he went back and told his men, I see God in all of this. Wow. Got to look up. Anyway, it's enough preaching for today. So much to do in 9 minutes. Okay. We integrate with respect to rho. So I have this integral from 0 to 2 pi, this integral from 0 to pi over 2, and that's rho squared over 2. That's evaluated from 0 to sine phi. And then here we have cosine phi, and then d phi, d theta. We can put that 1/2 out in the front, integral from 0 to 2 pi, the integral from 0 to pi over 2. So this is sine square phi times cosine phi, d phi, d theta. Why don't you finish that? We'll stop with this problem, and I have only 2 more problems left, but I'll work those on Thursday when we come back. This is it, 14.7. Yes, sir. Yes, sir. We're concluding with this section here. Yep. So the test would be on 14.1, 14.2, 14.3, skip 14.4, 14.5, 14.6, and 14.7. Okay? Makes you feel good. You thought you had some more to run. So, hey, we take a little break now, yeah, and just go back and make sure you get, what we've went over. So I'll give you this weekend to go back over those sections from 14.1 to 14.7, and we'll take the test on Monday. Okay? Yes, sir. Power over 3. That's what I got. And since you got that, I feel okay. So as long as I have somebody that agrees with me, if we're all wrong, I'm kind of okay with that, man. I'd rather we all be right or we all be wrong. And if you got 2 winos down there drinking, they're both wrong, but they feel good about themselves, man. And then we both losers. Hey, just pass me that cup, man. It's interesting about the philosophy of the winos. I've never seen them fall out and fight over their liquor, but I see so many sane folk fall out and fuss and argue over very simple minor things in life. Wow. They sure do, man. My Lord, my Lord. Some wisdom right there, brother. So if you get power of 3, you're free to go. Did you let u equal to sine phi? So d phi picks up that cosine phi, d phi, good. So you end up with sine to the third divided by 3. Yep. For the final answer, power over 3. Yes, sir. Y'all take care. Have a good one. Thank you. What happened, Thad? You take sine evaluated at power over 2. That's just 1 to the third power. What's sine of power over 2? Just 1. Yep. Yeah, man. It's still early. Yep. Just 1. So then there's 1 all over that 3. So you get 1/2 and 1/3 is 1/6. And then times 2 pi. So 2 pi times 1 over 6 is just power over 3. You got it. Good job. That makes you feel good, man. Yeah. Oh, boy. I thought about you, man. I said, you need to take this class, buddy. Amen. I know that's right. I'm fighting against that too.
I was watching a program on a serious documentary on Alzheimer's,
Mm-hmm.
and it is a serious thing going on.
It is.
And then I was thinking, they said, well, it's up 50%. I said, but maybe just
That's what my dad had. My dad had Alzheimer's. It's a very sad disease.
and fatal to what I got.
Oh, man, I hate it. The only thing that I could say about him that I noticed, that doesn't go in there. Can't do 2 things at one time. Was he liked salt.
He like what?
Salt. He put salt. See, that's the thing. See these tumors in your brain and all of that, and the salt affects it, man. The sodium. Leave the salt alone. Strokes, aneurysms, and even I think another connection is Alzheimer's. Sodium. And we would tell Dad all the time, that's enough salt, Dad. No, it's not. No, it's not. Man, leave the salt alone.
See, I've lived along, I say.
Yeah, those soda drinks, man. Yeah, I stopped drinking the soda drinks. So, well, I had a peach pop at church Sunday. I should have had that, but yeah, I tried my best.
Sugar or the salt
The sugar's not gonna. The sugar will throw off your glucose level.
Okay.
But here's the thing, man. All those things, they kind of work like with each other in a negative way. Like if you have, if you have high sugar or low sugar, and if you have bad, too much sodium, then it just makes both of them worse. It just magnifies.
One into their catalyst.
That's right. So, but I think a lot of this, guys, a lot of this stuff is going on. One is the salt level, and secondly, the sugar. And the sugar is not bad if it's the natural sugar. If it's not refined, it's just all the refined processed stuff that's messing us up. Because for it to be processed, they have to pack it with sodium just to preserve it.
I watched a documentary about like people trying to lose weight and stuff, people that are obese and stuff, and they go for this diet drink stuff, but in the end it's got so much sugar.
That's right.
Because like it may have like low calories or something,
Right.
like just to make it taste good, they're adding more stuff to it.
They are.
Than it originally like.
Yes, sir. Yes, sir. Man, hey, I just eat an apple. I just eat an apple, something natural, banana. Man, you can't go wrong. If God made it and if you're taking it from his hands, it's going to be good for you.
You know, I have been eat for breakfast.
What's that?
Well, I did for like 4 or 5 days. I just took a watermelon.
Watermelon is good too.
The fiber in that thing is unreal, like potato chips.
Yes, sir.
The fiber in that thing is unreal. And it's got a lot of water in it, and
That's right.
come on, coach, you obviously had to go wild.
I won't be there. I'm doing interviews today all day. So all day today and tomorrow.
Okay, all right.
Yep.
Let me get that.
Okay, you too, Thad.
Maybe I'll see you then. I'll get Thursday.
I'll be around Thursday.
Okay.
Yes, sir. Okay, buddy.
What time do you need to be on Thursday?
About
Thursday morning.
about 7:45.